Okay, now we'll go to example number two. It is for it's like a pipe with a pipe and a contraction, a sudden contraction in a pipe. We need to check the dimension analysis. For example, if we have a pipe with 1 meter and this one is half a meter, what it will be if it is this one less and this one less with the similarity. Okay. Okay. Same method. Either we know the formula or we use our logic. If we know the formula which is going to help us, we know that the pressure loss in the fitting it is K. K is a constant representing this one multiplied by rho V square over 2. Based on this, U it is a function of Reynolds number, and the Reynolds number is function of the diameter, the density, and the viscosity. Okay, and also we know that is this Reynolds number, and here also if you assume the k, it it is depending how much change in the, for example, is d1 is way bigger than t2, so k will get very high, and if d1 is almost d2, so k will equal 1. Okay, or we're going to use the logic that is, yeah, the pressure drop should be a function of d2, d1, the velocity and the viscosity and the density. Okay, either like this or like this, uses the logic or whatever. So we know that the delta pressure is a function of those. Number of parameters that we have is 1, 2, 3, 4, 5, 6. 6 parameters. Number of primary dimension, it is 3, mass, L, and time. Which is will be similar to number of the repeating parameters, which is 3. Of course, we're going to select rho, u, and d1, or rho, u, and d2. Don't select d1 and d2, both the same dimension, okay? Number of byes is 6 minus 3, it is 3 byes. So the first by m0 l0 t0 equal delta b, the primary dimension, the primary parameter, multiplied by the repeating parameter rho u rho power a b c. Same analysis mtl. Of course, use m then t then l because for fluid it is you will get the equation, because if you use l the first you will find an equation with two unknowns, and after it is better to go mtl. Okay. Then you will get the primary, sorry, the first pi, which is delta b over rho u square. Do the same concept for mu by 2, which is this one. By the way, we know this one, inverse of it, it is the same of it, so which is Reynolds number. By 3, apply, you will find it is d2 over d1. Okay. We know that by 1 will be a function of by 2 and by 3, so delta b over rho u1 squared is a function of Reynolds number and d over d2 over d1. Okay. We need to ask ourselves why we didn't say that delta b is a function of rho u d1 mu d2 and u2. Why? Why we didn't say, because like what we had done here, like d and d. Why didn't use also velocity u here and u here, like u1 and u2? Why you didn't do it? Of course, rho and viscosity is constant. Why you didn't do it if we're going to use the logic? It is very simple, because it is a function of other parameter. Remember, here, here, that is the parameters should not be function of other parameter, a direct function of it, which is mean we can state it like this. We know that the flow rate is constant. So area by velocity 1 equal area by velocity 2, blah, 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 blah. So velocity 1 and velocity 2, which is velocity 2 and velocity 1, equal d1 over d2 squared, which is equal to by 3 squared, which is by 3. What happened here? See, we know that is by 3, it is d2 by d1, and we know from QC u2 by u1 equal d1 by d2. It is okay if we make inverse shift up and left, it's okay, and even if we make it square, it's okay. What does that mean? Which is mean is u2 over u1 is a function of a pi, which is, of course, this pi will not equal to this one, but the point is it's dimensionless, constant dimensionless constant. So because of u2 is a function of u1 multiplied by, it is a u1. Yeah, it will not going to affect, and we should not take it. Okay. So the idea is if one parameter is equal to similar parameter, like here, velocity is equal to similar velocity but multiplied by pi or multiplied by a dimensionless constant, we cannot use it. Okay. So we cannot use, so cannot be used as pi equal u2, this is u2 is equal to u1 multiplied by 3 as u2 same dimension of u1 as a value of u1 multiplied by constant dimensionless constant. So it is simple example, but it is teaching us when we are selecting the parameters. So when we are selecting the parameters here, we need to use the equation or the logic. Even when we are selecting the parameters here, where if we use the equation, you will be in the safe side, by the way. Okay, because you it is like this, or if you use your logic, so you will try to take whatever all the parameters. Take care, for example, you need to ask yourself d1 and d2. Why I will take d1 and d2? If you took u1 and u2, you should not take d1 and d2. You should take only d1. But if you took only d1, it will be little bit mathematical calculation. It will little bit will be complicated. But the direct approach is to select d1 and d2, and u1 only, and you don't care about u2 because u2 is a function of d1 d2 u, and that's it. Okay. So at the start of the solution, how I still I didn't calculate the pi's. Okay, even if you didn't calculate the pi's, even if you write here the parameters, which is delta v, rho, u1, d1, and etc. So here and etc. u1, mu, and d2, and you write u2, you need to ask yourself for each parameter: is this row equal another row? Yes or no? There is no another row. There is no. But here we have d and we have d2. You get my use. And u1, for example, and u2. So you will ask yourself: is u1 is equal to u2 multiplied by a dimensionless number? From continuity, yes. And d1 and d2 is yes, but we need to select remove one and to keep one. Okay. Third example. It it will be like a little bit not complicated, but we are start to get a little bit more deep, like here's a submarine. No, we have a rocket which is has been shooted in the air with assumed angle alpha, and the length of the rocket is L, and voila, do the same procedure. Please, we need to know what is the drag coefficient, so the drag force. We need to make a model. We need to check the model and the actual, etc., etc., etc. Okay. So how many parameters we have? We already discussed it before, by the way, here, either from the equation or from whatever. But here we'll add one alpha. Okay. So maybe the submarine is shooting up in angle. It is same concept. So we'll have length, the velocity, the diameter of the rocket, alpha or mu, and c. Why I added c? Why I didn't add c here? Why you didn't add c? C. First, we didn't add c, and it was an approximation. That is, it is incompressible flow. As we know, we checked at the end that Mach number is less than 0.3. Rocket, from its definition, we know it is going to be over than 0.3. It's not supersonic, but it will not be less than 0.3, or maybe it will be more, or for sure it will be more than 0.3. So it will be a compressible effect. So we need to take C in account, okay, for compressibility to have a valid. Okay, so how many parameters we have? 1, 2, 3, 4, 5, 6, 7, 8. How many primary dimensions? Still 3. How many repeating parameters we're going to use? We're going to use 3. How many byes we're going to have? 8 minus 3. It is 5 pi. 5 byes. It is too much byes, yes. Then the first one, force, same concept, same procedure, MTL, then by 1 equal, same concept, it is coefficient, sorry, drag coefficient. Same, when we put it with D, it is D over L, the characteristic shape of the shape factor. Same, we'll do it with alpha, by 3 is alpha, just repeat the same, it is alpha. Of course, we cannot use the repeating parameter alpha. Alpha is dimensionless, and we don't want this one. And we cannot take V and C the same in the same parameters. You cannot say L, V, and C because C and L is equal. Okay. However, we already done it here. Where it is? When we are selecting the repeating parameter, we select U, rho, U, D1. We didn't even take D and D. You get my point? It's okay? Okay. Now repeat again for mu, etc. Same like before it with Reynolds number. And for C, same. Then you will find it is by 5 is c over v over velocity, which is the Mach number. Okay, so by 1 is a function of by 2 by 2 by 2, which is mean the drag coefficient is a function of the shape factor of the characteristic the characteristic for the shape. What is the diameter to the L ratio? Alpha, the angle, Reynolds number, which is the speed, the speed and the viscosity and density, and the Mach number. Okay, all of this is affecting this one. Okay, and as we agreed before, like here, if we are trying to calculate any calculation we need to do after the pi, we know that is CD should be constant. We know from this equation CD should be equal constant between the model and the actual. We know that is D over L should be constant. We know that is alpha should be constant, and we know that is Reynolds number is constant, which is mean if we're going to change the density or the viscosity, we know that the Reynolds number should be always equal constant, and we know that is the velocity of the rocket divided by the velocity of the sound, if in case of temperature change, should be constant. Mach number should not be changed. For example, if I change from air to argon, so R is a change, gamma is a change, so C is a change, so you need to respect this effect also as well. Okay. This one is regarding the last example. I think so. It will be a little bit opening another. So now let's return to the the final example for the dimensionless analysis. There is a very long small cylinder. We need to check as it become 2D, is it affect the combined with 3D? What does this mean? يعني, which is mean, can we assume or can we neglect the third dimension if I have a very long small cylinder? Is it okay to assume it is a 2D, which is mean like a small rectangular plate, and to neglect this diameter? Okay, based on 2D and inertial can be neglected. So if it is 2D, so the inertia component here can be neglected, which is mean the drag force, it is only due to the friction. Okay, and by the way, due to only the friction and the inertia, which is based on the density, there's no any effect for the inertia based on the density. As it will not make a major effect on the inertia. So we can even neglect the density. If it is very long L, we can neglect even L, which is mean L will never change in the length of that cylinder. So we can state that is the force is a probability of the velocity and viscosity and the diameter. So then, okay, but maybe somebody will tell me, no, 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 no. Let's keep the density. We should not neglect it. Then I tell, okay, if you cannot use the logic, so we go to return back to our equations. So we know that the force is a function of CF and CD multiplied by density. I know the density is in the both formulas, but bear with me. CD cross section, it is 0, equals 2D. It's remaining only CF. CF is multiplied by density, okay? Okay. What is CF? This paper is repeated. So okay. CF is a function of Reynolds number. Reynolds number is a function of the density, but Reynolds number always in the base, and density will be in the base. So which is mean density will go by density. Yes, you will tell me, okay, but this one power of 1 over 5 and all power, it is a correlation. It is a correlation. This power, it is because we are changing these numbers. It is depending on correlation, but at the end, uh, it can go to each other, and we can neglect the density effect. Okay. Okay. So again, you're based on 2D, inertia can be neglected, so we can remove rho as it has a major effect on inertia. Okay, it has very minimal effect on the viscous itself. Okay, again, again, it has a very minimal effect on the viscous. Okay. So same procedure. We have four parameter. We have three dimensions. So we have 1/3 repeating right. Make the same procedure. 1 by, so f1 it is a function of this, or by one is this one, which is by one is a function of all by's, which is mean f1 is like this. We know that is the force is a relation of velocity squared. This is an information we already know it, by the way. It is known. So our assumption is not possible because the force is a function of velocity in power 1. So that assumption is not possible. Also, we know that is friction is the force of the friction is proportional to Reynolds number, which is mean, and Reynolds number is a function of density. So based on this, the number of parameters, Reynolds number is function of density. So which is giving us that assumption here, which is I was trying to convince you, it is incorrect. So now using the logic, not always going to be correct if you are not understanding the full mathematical formulas. So again, if there is no inertia, there is no density, so forget it. But if we go to back to density, which is the first part I was trying to convince you, but it at the end, after you've done the dimension analysis, you get that, oh, your assumption is correct. Yes, it is going to affect. So density is going to affect. So this assumption is incorrect. So you need to put the density. So V mu D density, etc. Continue the calculation. So you'll get the CF with the first y, manipulate, it is VF, again, by 2, it is R, so it is, which is correct. So this example giving you, if you use your logic without knowing the formula, you can make a mistake. But if you put the formula and you start to say, okay, this one is parameter of this one is this one, you will understand it very well. This all in the dimension analysis. The last one in the dimension analysis, not this part, it's new completely part, is the similarity. If you do the dimensionless analysis for the pumps with all of its parameters, you can get the similarity curves, which is from the dimensionless analysis. You will get something named specific speed, which is a constant, and the specific speed we're going to go in detail later on. Yeah, the specific speed, which is for the pump, it is nq about to half divided by gh, and this constant, this is a pi. Okay, for example, this for the pumps, this for the turbine. Okay, this is a power. So this one divided by another model scaled, it is equal. So if you change the n and q and whatever, so it will be equal. If you change only the n, so n over n equal constant. You get my point? So it is going to give you this equation, which is a similarity equation of the pumps. How we got it? So pi over pi is equal 1, which is by anyhow is going to equal q over q. If you change these two parameters, which is the rotation speed, it is n or omega, whatever, and the diameters, or the head, or the power, p power, and this is a similarity equation, which is you can use it anywhere for pumps, fans, etc. Okay, so this is one of the application of the dimensionless analysis to put all the parameters to get the bias. One of the bias is the specific speed, which is pi itself. So for example, if you put pi 1, which is equal to pi 2, and the q here go here, q, you get my way, so divide together, so you find it n over g by g by pi, so it will be n over n multiplied by h over power to 3 over 4 divided by h over 3 power 4. Let's check the similarity equation. Voila, it is the same. Okay, and of course you can remove one part and put one part. Okay.